Yeah, so we just got our Lego sensors in the mail today. Gyro, EOPD, and accelerometer. We've never used these sensors before. We've used light sensors, programmed a lot with those last year. EOPD is somewhat similar, but we've never even used them. So we're excited to start working with them, and hopefully it'll help make our robot more accurate. So one of ours, the EOPD sensor, counts like a light sensor with 2 light bulbs. It has an internal light source, and so it can filter out ambient light. So it sends out a beam of light, reflects off an object, comes back, and it can read the distance. It's got an effective distance of about 6 to 7 inches, and it's got 2 modes, long range and short distance. And it's fine for shadows because when the sensor passes over the shadows, it has its own light source, so it's not affected. But if you switch between different types of surface, it'll make it less accurate because of the different reflection off the surface. But yeah.
And my sensor is the gyroscopic. Its primary use for navigation and measurement of the degrees that the robot turns. It is very hard to program. The sensor detects rotations and returns a value representing the number of degrees and the rotation is. You can measure up to plus or minus 360 degrees per second on rotation. Rotation rate can be right up to approximately 300 times per second. It makes turns more accurate.
And my sensor is the accelerometer sensor. It is useful because it can use up to 3 axes. Normally you program with the Mindstorm NXTG, and you can use the ultrasonic block to program with it on the x-axis. It measures -2 to +2 G's of force. And it is also called the tilt sensor because it measures the tilt of the robot. And it measures the acceleration of the robot, and the acceleration of each axis is refreshed about 100 times every second. And the scaling of the accelerometer sensor is approximately 200 counts per G of force, and the accelerometer sensor helps the robot to be more consistent in its movement.